Okay, well, welcome to the class lecture 7 for polymer matrix composite part 2 for the course of modern manufacturing process. Today we are going to talk about open mold process, closed mold process, and other polymer matrix composite fabrication techniques that are used in various industries or research organizations. So firstly, for open mold processes, it is basically the kind of casting method. Okay, the product that you want to manufacture, you need to create a outer shape of that product. I'll show you in detail in figures, but to talk about the introduction, actually, you make a certain shape and then you put the fiber and resin on that shape with desired thickness that you want, and then you leave it for curing, and then you remove the part. The most commonly used resins that is being used currently is epoxy polyester, along with fiberglass or any other natural fiber or synthetic fibers that can be used to manufacture polymer reinforced fiber reinforced composites. And most of the cases, the moldings are usually very large, kind of. If you look at the speedboat, when you cross the river Padma on the using the speedboat, you'll if you look closely on the bottom where you put your feet, it is actually glass fiber reinforced composite. Okay, with polyester as resin. The complete hull that is used in those kind speedboats are made of polymer reinforced composite. Sometimes sharpening boards are also, and also the outer shell of aircrafts. Sometimes the train body, or also in the case of, if we talk about the marine sector, then the hull and the deck and the cabins are made of this kind of polymer matrix composites. And the advantages of using an open mold is basically very low cost. You make the open mold, you put the fiber and resin on top of it, and then you do the curing. But the problem with this is that when you cure it, the surface that are in contact with the mold surface, that you will get a very finished surface on that, but the open surface will be irregular. If you don't need the regularity on the top surface, then you can use the open mold process. Otherwise, you might have to do some machining to get the surface plain. Or else you can go to the closed mold process. There is some other disadvantages on the closed mold process too. And for best possible part surface finish, you need to make the mold really polished, so that you get a really polished or plain surface in contact with the mold. If the mold surface is finished properly, then you will get final product will also be very much finished. And in this lecture, we're going to talk about 3 types of open mold process. First one is hand layup, and then spray up, and then automated tape laying machine. First, the hand layup method. It's a very simple type of method for manufacturing polymer reinforced composite. Firstly, if we look at the first figure here, in this figure, in the first figure here, what happens is that you have the open mold. This is the open mold that you a cross section of the open mold, actually, for a boat hull. Okay, and firstly you spray mold release agent. After curing, to make the removal of the part easy, you have to apply mold release agent. It's kind of lubrication, so that you can remove the part very easily. First you apply the lubrication, and then you apply gel coat. It's called gel coat, a small thickness of resin or pigmented, possibly pigmented to color. That means the color that you want on the finished surface. On the finished surface here, the color you can add also the colored resin to get the surface very finished or look really nice. You apply the gel coating, and after that you apply your required successive layers of fibers. you put the fiber mats here, and then firstly actually you use the resin layer, and then put the fiber, and then you again put the resin, sorry, fiber layer, and then again resin. Okay, how many layers you want, you can calculate that, and you put that much resin in there. And the function of the roller is that to roller is not like it's not like a plain roller. The roller actually have groups. Okay, it's kind of like this irregular surface roller, uh, so that resin can be distributed evenly on every empty spaces of the fiber mat, okay, for even distribution, as well as to remove the air bubbles that forms due to the application of resin on top of the fiber mat. Okay, and roller has two functions. First is to distribute the resin evenly on the surface, on the fibers, and to remove the air bubbles. And once the required amount of layer has been placed in position and the rolling is complete, then you just keep it for curing. There are various curing methods, so we'll talk about that in the later slide. When we finish all three processes, then we'll talk about the curing methods. Then you apply the curing. It can be temperature, or it can be time, or it can be pressure. And then after curing, you remove the part, and that will be your finished part. And the outside surfaces has to be trimmed to get the desired outcome, the final finished product. Okay, that is the basic hand layup method for manufacturing the fiber reinforced composite material. And the method that I talked about so far is actually the wet layup method. There are two types actually. Hand layup method has two types. First one is the wet layup method that I talked about, and pre-prex layup is a slightly different type, where you don't need to actually apply the resins. Okay, in that case, we already talked about the pre-preg. Pre-preg is the partially cured mats. Fibers are filled with resin, and the mat contains the resin, and it is partially cured and flexible enough to give it any shape. The partially cured flexible pre-pregs are placed in position in the mold, and then using the roller, you can adjust it to make the corners, sharp corners can also be obtained in this way. And then you put required amount of layers of pre-pregs, and then you shape it using the roller, and then you use the curing, and that is the pre-preg layup method. It's a very simple technique. And the pre-pregs are widely available nowadays, either carbon fiber or glass fiber. There are a lot of fiber reinforced pre-pregs are available, and the pre-pregs are those mats which actually contains the resin. You don't need to apply the resin in this method. Okay, so do you have any question in here? All right, then we move forward. The second method is spray layup method. In this case, actually, this method is basically used for chopped fibers. That means short fiber composite or discontinuous fiber composite, we can say. In this case, the fiber lengths like 25 to 75. It can be less than that, less than 25, but not more than 75 millimeter. It will create problem when you use more than 75 millimeter fibers. In this case, the resin and the fiber are sprayed on the surface of the mold simultaneously. Okay, you put using a nozzle, liquid resins are supplied using the nozzle spray, and the fibers are cut simultaneously. There is a roller and cutting arrangement. Continuous rovings are provided through these rollers, and the roller is timed in such a way that the fiber length can be maintained. The equal length fibers are cut through this roller and also placed in position. And before placing into position of the on the surface of the mold, it gets mixed with the resin in this region. Okay, and then those resins get stick to the surface surface of the material. Resin with chopped fiber sticks to the surface of the material. Then at the end, you can use roller to compact the fibers so that you get a highly dense structure. Otherwise, it will be porous and there will be air bubbles present in the material. Okay, and then once the rolling is complete, then you keep it for curing, and then you remove after curing. Okay, and the applications are also again the boat hulls, bathtubs, shower stalls, automobiles, track body. A lot of applications actually nowadays for composite material, because they provide lightweight and better strength. Okay, and if you want to say in a single word, single term, that is a specific weight of this material, or that means the specific strength of this material is of the composite material is very high, and that is why it is a very popular material to be incorporated in various industries. Okay, okay, any question here?
No, sir, we can proceed.
All right. And this third one is the automated tape laying mechanism. This is kind of an advanced mechanism for machine for manufacturing the fiber reinforced composites. And this method actually uses the prepregs. Okay, the prepregs are laid up by a CNC machine. The function of this machine, I'll show you. Hang on. If you see this, see, the tapes are being laid on the surface using the CNC machine or robotic arm. Okay, the robotic arm is actually doing the job instead of human interfere, and this machine can move in X, Y, Z 3 different directions, so that you can put the required region is covered by this machine, so that you can put the tapes or prepregs on the surface, and you can define everything, like how many layers you would like to apply, and there is also a cutting mechanism. Like once it reaches the end, then it automatically cuts the tape. Okay, so this is the method for automatic tape laying machines using the prepregs. This is a very advanced technique nowadays, and there is a lot of work currently being done on these automatic tape laying machines, because there is a lot of research gaps. Because if the plane surface is very easy to maintain, but if the surface is like very if the surface is like not regular, in that case it is very difficult to maintain. Okay, so for example, if I say something like, if the surface is like irregular, then the tape laying would be very difficult. Okay, using this type of machine, but the technology is advancing, so it will come to soon, very soon. Okay, any question here? Okay, so for the curing open mold processes, the curing required of all thermosetting resins used in FRP laminated composite, thermosetting or thermoplastic, whatever resin you use, you need to have the curing. Um, Basically, the curing has three different parameters. Okay, the time, temperature, and pressure. Sometimes you need to apply certain pressure and certain amount of time, and the temperature. These are the controlling parameter for curing. Some resins are cured at high temperature, and some resins are cured at room temperature. Some resin takes like 1 hour to cure, and some of the resins take like 24 hours to cure, or more than that. Okay, so time, temperature, and the pressure. If you put it at very high pressure, then the temperature might require less. Okay, so these are the controlling parameters for curing the fiber reinforced plastic composites. Curing normally occurs at room temperature for many resins, okay, and some other resins in cases you need to probably heat it up. The moldings made by these processes are often large, so that the board hulls or automobile structures, those are really long, and heating would be very difficult due to the product size. You need to have like that huge amount of huge volume of oven to cure them up, and the shape will be irregular, so you need to have really large volume for heating. So most of the cases, the resins that are used for large structures are basically the resins that cures at room temperature. Okay, that's what I said, like days are required before room temperature curing is sufficiently complete to remove the part. Sometimes you need like 24 hours for curing. And oven curing provides heat at closely controlled temperature. If the resin require very close control of the temperature, and also sometimes you need to have vacuum, then there is a limitation of part size. Sometimes the part size cannot be larger, so to avoid the large volume of oven. Okay, and also the larger the specimen, larger the product, and large amount of vacuum pressure is required. In that case, you need really high capacity vacuum pumps in that case. And second one is the infrared heating. Some of the resins available which actually cures under the infrared light. When you apply the infrared light or infrared heating, then those resins gets cured. Like one of the example I can say, like dental composite that actually cures at using the infrared light. Okay. And the curing in the autoclave. Autoclave is a kind of oven to you can closely maintain the temperature and pressure inside the autoclave, and small parts are often cured in autoclave. Some of the epoxy resin actually needs autoclave for curing. Okay. And in fiber reinforced composite processing, it is usually a large horizontal cylinder with doors at either end. It's basically the autoclave, the description of the autoclave. Okay. At either end. The autoclaves are like cylindrical structure, and inside you can heating mechanism is there, and also you can control the pressure. Okay, so this is the curing methods for open mold processes. Okay, any questions? All right. So the second process is like closed mold process. It is very similar to casting actually. Uh, uh, the products are made between two plates with a cavity inside. The finished part will be the shape of the cavity that is inside the mold. Okay, in this case, the wall surfaces of the product will be really finished surfaces can be obtained, and the production rate is very high. It takes very small amount of time for curing, and the closer control over our tolerances. Like if you want to maintain the dimensions really strictly, then you can use the closed mold method, and more complex and three-dimensional shapes can be obtained in this case, because you know the casting, the benefit of casting method is that intricate shapes can be made. Any type of shape can be obtained using the casting method. So and that is also same for closed mold processes. And these three different categories it can be divided into like compression molding, transfer molding, or injection molding. If you look at the compression molding types, in this case actually we already talked about this, like sheet molding compound, bulk molding compound, and thick molding compounds. These sheets actually, when partially cured, and then they cut into proper size and they put it in a mold, and then using the other half of the die. It's kind of a die. Okay, in the other half of the die, you can actually, for example, if I want to show you a little schematic for that, it's like, let's say you have a die like this. The first half of the die is here, and you have a composite like bulk molding compound sheet, and that sheet you would like to form like this. Then the sheet will be placed in here, something like this, and then there will be other half of the mold. Sorry, it has to be a little bit up. Then that, oops, it's not going to be like that. Hang on. So this is another half of the mold. You put the compressive force in here, and then this mold actually compresses this sheet and gives the final shape like this. Okay, the final shape will be like this. Okay, so this is how the compression molding is done on sheet mold compound, or thick molding compound, or bulk molding compound. Okay, and then once compression is done, then you apply the curing, either temperature or time. Okay, then the curing is done. Or sometimes when you want to use like the fiber reinforced composite with chopped fibers, then you can just put chopped fiber reinforced composite in here, and then use the compression to distribute the material into the mold. Okay, then you'll get really good output. And the preform molding, it is also the closed mold process. It has two half. Okay, in this case, you lay up the fibers outside of the mold, uh, uh, one after another, and then you put once it is complete, and then you use the other half of the mold to give it the required shape on the fiber mats. You give the required shape, and then you introduce the resin into that. This is also called the resin transfer molding, but in the preform molding actually it's not similar to the resin transfer molding. I could not find the picture of that, and that is why I'm using this. But in this case, the resin is not transferred like this. In this case, the layup actually contains the one layer is fiber, another layer is the resin layer, and it is not liquid resin. Okay, it is like polypropylene sheet or polyethylene sheets can be used here, and then another layer will be fiber, another layer is resin layer, something like that. The layer by layer, this are placed, and then those layers are placed in the mold, and the other half of the mold will compress it properly, so that compressing and heating will be applied at the same time, so that the sheets of the resin gets melted and distributed over the fiber mat. Okay, that's how we produce the preform molding. Okay, and the resin transfer molding and vacuum assisted resin transfer molding are the similar method. First one actually uses the positive pressure to impregnate the resins into the fiber, and the second one is the vacuum assisted. That means the vacuum is created to impregnate the resin into the fibers. These are methods are same, like you do the layup initially, and then put it into the mold. The mold is closed, and after closing the mold, you introduce the resins through the hole provided at the middle with a positive pressure, high pressure. Then the resins get distributed over the whole area. Okay, resin gets distributed over the region or through the empty spaces of the fibers, and there must be some method to get the air bubbles removed from the resins. So there is complication in the case of resin transfer molding. Often the bubbles are created into the parts. That is why the vacuum assisted resin transfer molding has come into effect. In this case, what happens is that you do the layup, and then you apply the vacuum using the vacuum bag. There is a support in there. Okay, and vacuum will be applied in here, so that the material is compressed. At the same time, due to the application of vacuum, the airs will be removed, and the resins will be penetrated into the fiber empty spaces. And in this case, this is the excellent property can be obtained, and also the voids that are created in the RTM method is completely can be completely eliminated using this vacuum assisted resin transfer molding method. Okay, any question here?
So why vacuum pressure, not positive pressure?
The positive pressure is used for RTM. That means resin transfer molding. In this case, you apply the positive pressure to impregnate the resins into the fiber empty spaces of the fiber. In that case, the problem is that air cannot get escaped from the system. Okay, and the problem is air gets trapped, and that creates problem. in manufacturing. And in this case, what happens is that you apply the negative pressure, that means vacuum pressure, to remove the airs between the fibers. Okay, and because of the suction pressure, the resins gets into those positions.
But sir, in case of this case, it has a chance to escape the resin due to the vacuum pressure.
Oh no, there is a method provided in there. Like if you have a tubings, okay, you have a tubing in here, and there is a it is called accumulator placed in that place, and then from the accumulator it moves to the vacuum pump. Okay, the air is getting out through this way, and once the resins are applied on the other side, when the resins get into the position, then the extra resins comes and drops in here. Okay, so it will not affect the vacuum pump.
Sir, thank you, sir.
Okay. And the last one is the injection molding. It is very similar to the plastic processing method. It is mostly, the injection molding is mostly used for chopped fiber. The fibers are chopped into small length fibers and then mixed with the resin particles. Okay, mixed with the resin particles and then applied in the hopper. Not only pellets plus fiber are mixed in here. Okay, pellets and fibers are mixed in here, and then that mixture is introduced into the vacuum into the screw, where the temperature is maintained so that the pellets get melted and the fibers get mixed into the resin, and after mixing you transfer them into the mold, and after curing into the mold you actually remove them. For thermoplastic resins, most of the cases thermoplastic resins can be used in this case, and sometimes thermosetting resins can also be used, like you impregnate into a mold, and then the entire mold is transferred into the oven for curing. Okay, that can also be done. Another one is the filament winding method for other shaping processes of the polymer matrix composites. I think you have already seen that there are some cylinders available, the composite cylinders, lightweight composite cylinders from Bosundhara Group.
CNG, right, sir? CNG.
Yep, for the gases, LPG gases.
Domestic use, sir. Yes, sir.
Yep, these cylinders actually made of this kind of winding. There are different types of windings actually available. This one is the filament winding method. The fibers are actually dipped into the resin bath, and fibers are mixed with the resin, and then the fibers are winded into the cylinder. If you want to make a cylindrical cylinder using the fiber reinforced composite, then composite rovings are dipped into the resin bath, and after that you take it out and wind it on a mandrel. The mandrel is rotated, and this one moves left and right. The carriers moves left and right to apply the winding all over the cylinder. Okay, so this is the filament winding method. After the winding is complete, then you apply the curing. Okay, and that's how those cylinders are also made using this method, filament winding method. And winding can be like this.
Using the filament winding method, how we have to put the filaments on the top and bottom part of the cylinder?
Top and bottom part of the cylinder means?
Sir,
The terminals. I mean, sir, say the
these ones?
two round side on the sides.
This side and this side.
Right, sir.
No,
Right,
this two side is okay, sir. But for the cylinders where the shaft is there, the shaft center line.
Okay,
this side.
Okay, you don't have to put the filaments on that side, because you are creating a hollow cylinder, right? This is the inside diameter of the cylinder that you will get. And the filaments are winded on top of it. So certain thickness, after obtaining certain thickness, you stop the winding and then you keep it for curing. Okay, so this is the inside. The cylinder surface is actually the inside diameter of the hollow cylinder that you are producing. It's not continuous. Okay.
Sir, excuse me, what I was asking that on the top and bottom,
yes,
it's
top
round
and bottom it's round.
kept upright. On the cylinder is kept upright. Say it's a gas cylinder. So
Okay.
on the bottom side there is round. On the top side also it's round.
Yep, this is round and this is round. Okay.
Exactly, sir. Now those part, are they, I mean, fabricating these things separately, then they are, I mean, joining these two parts, cylinder and the, say, it's a round shape thing. It's a
Okay.
circular
If you, for example, if you want to make a spherical thing like a football
right, sir.
using this method, like that was your question, right?
Yes, sir.
Yep.
Yes, sir.
In that case, one method that I know of is that a expandable rubber ball is used. Okay. A expandable rubber ball, like for example,
Sir, balloon.
balloon.
Sir,
Yep.
balloon can be used. Yes,
Exactly. The balloon is inflated like this, and then filaments are winded all over or around it. Okay. And
then
after the
winding is
curing,
done around it. Okay, sir.
yep. And after curing, you take the balloon out. Okay.
Okay, sir.
Yep. And in the case of the cylinders, gas cylinders, actually it is a steel structure, very
Right, sir.
thin steel structure. On top of steel structure, the fibers are placed. Okay.
So ultimately, the inside layer is the then a steel structure,
Yep.
sir.
That is a steel structure,
Sir.
but very thin. In the case of metallic, it's a very thick cylinder, right? Like almost 4 to 5 millimeter thick,
5
thick
milli, sir.
steel pellets.
5 milli.
Okay. But in the case of this, you just have to use a sheet material, sheet metal to make the internal structure, and then on top of it, you put the filaments.
Sir.
Okay.
Sir, thank you, sir.
And this one is for if you want to make the continuous solid cylinder. Okay, you don't want to make the hollow cylinders. If you want to make the solid cylinders using the fibers, then this is the method. Pultrusion is the method that is used to manufacture the solid cylinders. Okay. And in this case, what happens is that you have a lot of filaments available. Those filaments are dipped into resin bath, and after removal from the resin bath, they goes through a pre-dye former. This pre-dye former actually gives the shape, whatever shape you want. For example, you want the shape to be triangular, then the triangular formation is done in the pre-dye former. And once the formation is complete, then in this dye, actually the curing occurs. Okay, the curing, whether it is temperature, mainly the temperature curing, okay, or the time, it can be time. Then through this dye, the material passes, then gets cured, and after curing, this pulling roller actually pulls the whole system. There is no other system. See, so only these rollers actually pulls the whole thing, and then after required size, you can cut it out at any place. This is called the pultrusion. A lot of fibers. These fibers can be like yarns. Sometimes you can use the single fibers, or you can use the yarns. Okay, whatever you want. And the compression is also done in here, in the pre-dye former. Okay, after compressing, it gets the desired shape, and that shape is continued through this dye, and gets cured at the same time. Okay, any question? Okay, so for the next one is the pulp forming. Sometimes you don't want only straight parts. In this case, pultrusion, you get like only straight beams, okay, of different cross section. It can be of different cross section, but if you want a certain curved shape, so you can also obtain that. The process before the shaping die is the same, and after that you use a die shoe and the rotating table so that you can bend the whole structure to get the desired bending of your final product. And the curing occurs in here. Okay, the partial curing occurs in the shaping die, and the final curing occurs in this region, so that you get the permanent bend shape. Okay, and the cross section of the bend shape can be anything that you want. Okay, this one is rectangular, or you can make cylindrical, or whatever the cross section you want. You can obtain that using the pulp forming manufacturing for polymer reinforced composite. Okay, any question? So that's all for today. Actually, for manufacturing the polymer reinforced composite, the various methods that we have studied in here. And in the next lecture, we're going to talk about rubber processing and shaping. And that will be the last lecture, I hope. And Okay, let's see in the